you might have noticed, AI is a critical component on almost every organization's agenda. It's in some organizations the only thing that's being talked about. When you're in leadership of organizations, you wonder, what do I do? You don't really want to miss the boat, but you also don't want to be a first mover, where you perhaps make some of the mistakes that you should avoid. But if you're too late, maybe somebody else is going to implement functionality or do things with AI that you should have done earlier. So there's an eagerness to leverage AI for growth and innovation, but a bit of lack of sureness on how to do that really well, how to do it in a strategic and a smart fashion. That's what we're going to talk about today. This is what we see at SIG and how we can help. My name is Werner Heijstek. I'm a Senior Delivery Director at the Software Improvement Group, and I'm joined here today with my colleague Rob van der Veer. Rob?
Yes. Hello, everybody. Rob van der Veer is the name. I'm Chief AI Officer at Software Improvement Group, in AI for about 33 years now, and having a lot of fun these days. What a time to be alive, Werner, right?
Yes, and I think you're exactly the right guy to talk to about this topic. You already hinted a little bit at the amount of time you spent at this topic. You were into AI before it was cool. So you were exactly at the right point when the wave started gaining steam. So there are different ways on how to relate to AI as an organization now. I think you can use generative AI as a sort of as code assistant to develop software. You can develop AI systems yourself, or perhaps you're in the mode of getting AI ready. And I'd really like to talk about all three of these topics to you today. So let's just dive into the first one: the develop code using GenAI assistants. I think even as some organizations say, we don't want developers to do it. I don't think they actually have control over that. I'm 100% sure that all developers are doing it to some degree, and if they're not allowed to, then they'll find a way. So why are they doing this? Why are they doing it anyway?
Yeah, they should do this. So in my work, I talk a lot about the risks and the downsides because those are very important. But let the record show that I'm a big fan of using AI in software engineering. Right? It will help you create code faster. It's pretty good at creating test code. It can create documentation faster. It can also help you understand code quicker. It's like you have a programming buddy. But this buddy is from another planet, right? It's not a person. It's also not a perfect person. It has issues, and we have to keep that in mind. So what's important to know is that you still need to deal with code. You're typically still writing and changing much of the code yourself, and then you can gain that benefit for sure.
Yeah. So at what point does it become vibe coding? Vibe coding is this commonly used term. I'll vibe together a nice new application for my organization, but that doesn't cover this entire topic, right? So what is the distinction there?
No, it's being used quite broadly, and you and I also use it sometimes to refer to AI-assisted programming because that doesn't sound as cool as vibe coding. But the pure meaning of vibe coding is that it's at the far end of the spectrum of AI-assisted software engineering, where you no longer work with code. You just type in requests in prompts. Build me a website for my bridge club.
Sure, yeah.
You don't have to be a programmer. Now, we don't see our clients doing this, and that's for a good reason. They only use it for some quick prototyping, but our clients are large enterprises and government organizations, and vibe coding projects lack a language that is designed to serve projects like that. They do not provide abstractions, reuse, layers, encapsulation, testability, all these things that matter if you need to maintain something and change it along the way, especially if things are complex. So vibe code has its small place, but it can be fun and useful and quite enabling for sure.
Yeah. Or perhaps maybe more in the prototyping phase and in the actual production phase.
Indeed.
Getting stuff live. Yeah. So I recognize what you say, and I also see it that organizations more and more rely on GenAI to write code for them. I also see that organizations really want to put their foot on the gas and really find a way to do way more of this. And some organizations are very ambitious. You already mentioned some of the pitfalls, some of the risks. Can you expand on that a little bit? So what are the let's say you go all the way. So what are the key pitfalls that you'll encounter on that route?
Yeah, at first you'll go faster, as we discussed, and you're generating code, but that code often contains errors such as bugs, security risks, maintainability issues, and this is because AI has learned from existing code. And as you and I and many of the people in IT know, existing code is not perfect. So these AIs are also not perfect. Research shows that 40% of AI-generated code has security vulnerabilities. And then there's the matter of architecture issues. AI typically, and this is important to realize, does not follow system-level architecture guidelines. It's not part of your team. It hasn't seen the same training, hasn't seen the same code base, so it can create undesirable dependencies between components, for example. This is what most developers see. AI tools lack the context of the code base. They lack the insight into the internal architecture and company knowledge. So it's creating technical debt, makes mistakes that are different from the ones that people make, and they do this at an unprecedented pace. Now, this makes code quality measurement and management more critical than ever. And part of that is manual code review. So picture this. A lot of code is being generated containing many issues. Code review is already an activity that is under pressure. We see this in many teams, and typically is performed by the more experienced programmers who really don't like it. So there we are, the perfect storm for development teams rushing code out with a lot of technical debt in it. So keeping a check on that is one of the bigger challenges. Yeah.
Yeah, so but interestingly enough, it sounds like an old problem of speeding up, rushing to market, and this is essentially putting that on steroids. Just as an aside, why are there so many mistakes in generated code? Why does it contain so many risks?
Yeah, it's not just the fact that mistakes are in the training data, right? Because most AI these days is machine learning, and most of that is generative AI these days. At least that's where much of the attention is going, and it's being educated. It is behaving along the patterns it has discovered in the data, the training data. So in the case of many of these large language models and ChatGPT, basically the entire internet, which contains mistakes. But even if the internet was completely perfect, then AI still can make mistakes because it tries to see patterns. It's like associative reasoning. Based on patterns it thought it discovered in a lot of data, it derives to its conclusions. And if these conclusions, which are essentially guesses, are wrong, they're called hallucinations. And AI simply doesn't always understand how the world works. And that's intrinsic. It's the strength of the technology, but it's also, therefore, its weakness. So these hallucinations, even though sort of if you project all the improvement that the AI is going through, it will not go away.
Yeah, we'll get back to that later because it is often, why isn't the answer more and better AI? But first I'm curious, because what you say is, it makes sense to me, but it's very theoretical. Do you have concrete examples where you show the effects of these hallucinations?
Yeah, we recently saw some examples in the code that we looked at of what was called package hallucination and what is now called slop squatting. There's actually an AI completely making up a package, a component, an open source component, that it figures, well, this must exist, so I'm going to download it. And that seems like a harmless mistake. But the problem is, if this package doesn't exist, you normally get an error. Yeah. But attackers know about this. So they can put this package, this open source component, in a repository, and it will get downloaded. And one of the researchers, Bart Lanyado, who was one of the original researchers in this area, he put a package online to create connections to ArangoDB, and in a week he got 100,000 downloads of AI-generated code who were basically downloading sort of a random package from the internet that can contain all kinds of malicious mistakes. And I think what's so illustrative about this example is the fact that a human would never make this mistake. And it's based on sort of a misunderstanding of how the world works. So it's, I think, a good examples of things that we need to be aware of.
No. So what I hear you say is lots of code is being generated, whether we decide to or not. And you started off by very explicitly saying that's a good thing. Let's not do that. But the code that comes out can be challenging from a different perspective, can have risks for an organization. So how do you battle that? What do you? So you definitely you made it clear that we need to do this, but what's the next step?
What's important is to keep a check on software quality, and there are multiple ways to do this. And the way we help clients with this is we provide our platform to measure software quality, but not just on the code level, but also on the architecture level. Especially there is where you see things going wrong with AI code generation. So with AI, you really need to measure the quality of the code.
Okay.
And this has become increasingly a challenge because teams are using new tools all the time. They use one tool, Cursor, and then a week later, they use another tool because they want to benefit from the AI and play around with things. So all the standard ways of controlling quality, code review, coding guidelines, all kinds of tools that developers use are out the door. So organizations need to standardize on how they measure quality to keep this problem in check and to prevent this technical debt to proliferate. And that's where we provide our clients with our Secret platform. Measure, analyze, track software quality over the whole portfolio, code-wise, architecture-wise, from Cursor to COBOL, from visual programming to C++. And because of this single glass pane, that platform is ideal for managing AI-generated code and architecture at scale. So that's the main way we are helping clients with keeping this in check.
So, but then to get back to an earlier point, why not just use another GenAI system, another LLM for this? And why would I need a system that looks at the output when I have another LLM, and that maybe GPT-6 or 7 will be great at, it's saying, sorry, but check this code, and if you find any security vulnerability, fix it. Why not go that way?
Yeah, the big technological promise. If there only were a free lunch here, but there's not. First of all, these LLMs, they don't have the full context of the system, the code base, the architecture, the users, and what the users need. So they can't apply that knowledge in improving the thing that another AI that is also lacking all this.
But can't I prompt it? I read, I was at KPMG, they fed a 100-page prompt. And was it the Dutch tax code? I'm not even sure which country it was. And now they've created a tax advisor.
Yeah, we put the whole internet into ChatGPT, and still it hallucinates. So it's just it's not perfect, but it goes a long way. But there's a limit to it. So reviewing code requires more skill than the skill necessary to write the code, because you're looking for the nitty-gritty details, the things that went wrong. And that's where people overlook things. And that's where LLMs also overlook things. And especially because LLMs, they apply what you can call system one reasoning, right? Associative reasoning, very intuitive. And that puts limits to what they're capable of. So there's a reason that they produce so many security vulnerabilities in the first place. So there's a limit to what they can do regarding improving code. Research shows that they miss a lot of issues. This is inherent to the technology. So you need static analysis tooling that look deterministically at your code, and you need code review. And AI assistance in this process is great. You can use it to do some scans, use some output, integrate it, but it's not your ticket to perfection, unfortunately.
Can we linger for a little bit more at that deterministic remark? Because to me, it feels like there's much of the distinction hangs there. Because still, I would say, well, the LLMs a year ago had a bachelor's degree. I think now they're promising PhD level sport. So maybe the next one is Einstein or better than any human could ever be. So at some point they should deliver us fewer security vulnerabilities. Now you're claiming no, because of the nature of the technology, and you will need deterministic scanning. Can you expand on that a little bit?
This idea of limitation is supported by the great minds working on these AI technologies. It was also Sam Altman who said that the solution is not into bigger and bigger LLMs. You need some reasoning capability that is more based on rational reasoning than associative reasoning to accompany the AI. So we're talking about a hybrid model. And yes, we're making some progress there. But if you look at the fundamental research that's going on in this space that is promising, much smarter and foolproof AI, that is hardly making any progress. So yes, if you project the enormous increase that AI has gone through in capability over the last 2 years, you would think, well, at some point it's going to fix all my code, but it's not the case, and this is underlined by the people who have initiated all this innovation.
I find this fascinating because, of course, we're a little bit of so part of what is being talked about is slightly hyperbole, hype, whereas if you look at what GenAI can do, it is amazing, right? So the truth about how to use it most effectively is somewhere between the hype and the awesomeness you can see when you use it yourself. And this for me really helps to fit it. To say, okay, you can really it can do stuff for you, can make stuff for you, but you need to make sure that you sort of encapsulate it with deterministic, sort of more context-aware systems. You can augment it, and I think there are interesting ways of doing that, right? Using MCP, or there are other ways of orchestrating that collaboration, so you sort of get the best of all worlds. I think we'll hear way more about that. But I want to pivot a little bit because we're talking about multiple use cases. I think now we talked about GenAI specifically and coding, but there are also many organizations actually building AI systems. I think MIT wrote a relatively negative report last week, or at least they released it last week, where they claim that it often doesn't really bear fruit in the short run, at least. Let's first things first. What is an AI system? How do you define them?
Yeah, I sometimes do AI training, and we talk about the definition of AI systems, and there's a lot of edge cases that are quite confusing. The essence is that, let's not talk about these edge cases and the perfect definition.
Yeah.
The essence is that most AI models these days are machine learning models. They predict, recommend, decide, or produce content based on patterns that they picked up by being trained, but which takes place by looking at a lot of data that has examples. So they see a lot of examples of cats and dogs, pictures that have been labeled cat and dog, and then they learn how to distinguish pictures from cats from pictures from dog. That's the essence. That's most of AI these days. So you program the behavior of the model with examples, not with code.
Yeah.
So what is an AI system? Well, you need code to make that model into an application, and to control data flow and build an interface, an API, and also prepare all that training data, do experiments. And that's all programming. There's a lot of code involved. Also, when we look at our clients' AI projects, a lot of code. So AI systems are software systems, and engineering them is basically the same as a software engineering, with a few attention points. Now, we embraced this idea, and a couple of years ago at SSG, we created a framework for this. We extended the regular software lifecycle with practices for machine learning, and we helped clients mature the AI engineering with it. And we donated this model in collaboration with Leiden University to ISO, and it became the ISO 5338 standard on AI software lifecycle. And it's really helpful to view AI systems as what they are, professional software systems, because they require version management and CI/CD and documentation and architecture and security, just like we used to with software engineering. There's just a whole bunch of attention points that you can use to extend your existing professional processes to create AI systems.
So yet, if yet if you group them, and you've seen quite a few of those systems, yet if you group them in their own category, they do seem to suffer from specific challenges. And so if you look at the in the larger benchmark of software systems, you look specifically at systems you could categorize as AI systems. I do think you see specific challenges there. Can you expound on those a little bit?
Yeah, I've been a data scientist myself, and I hope my code from back in the day never gets discovered. That will be archaeological find.
Was it R or Python? What did you use back in the day?
Oh no, it was no. I'm not even going to say it. It's going to be held against me. No, it was terrible. But this still is a little bit the case because data scientists have been trained and managed to create quick insights. Build code to do that and quickly build a model. And it's sort of really experimental throwaway kind of stuff. And if we look at AI systems, we see that this way of working continues in the systems in production. They didn't start over after the experiments. They took the experiments and sort of fixed it and put it online. You can see that from a complete lack actually of testing code because the software isn't even testable. There's no abstractions. If you look at our benchmark and look at the AI systems, we did some research into that, is that 3/4 of the AI systems score well below the industry benchmark. So why is this happening? People have been data scientists have been incentivized in the wrong way. And now, since AI is more and more going live, they need an incentive to improve this. And if you look at their code, it's long lists, long units of code, long procedures, no abstractions, unfocused. And it's not that they are bad people. They get the job done, but the job is changing. So their work needs to become more like regular software engineering, including documentations, versioning, and creating automated testing, for example.
Yeah, in a way, it sounds like many decades ago, the software crisis led to the term software engineering, where the consensus was we should be a little bit more professional in how we go about putting together software systems. They're not quite like bridges, but also not completely not like bridges. There are best practices, there are patterns. In a way, this sounds like that this is a new group of people at the table of software development, and we need to get them through that sort of maturity cycle. So how can we help? How can we actually get them to that level?
Yes, I really love working with these data science teams because they remind me of what kind of a software engineer I was back in the day. Well, we know a lot about software engineering. So we can, we're SIG, Software Improvement Group. So we can help these AI teams to professionalize. We look at how they work. We assess their maturity. We have that framework that I talked about, right? The ISO 53381. Yeah. Give them a roadmap to make further steps. This is advisory. This is interviews, looking at artifacts and helping teams mature. Of course, we want to measure what they produce. That's the first thing that these teams start to do. Get immediate feedback on their level of quality and set a bar on it and make that happen. And the great thing about how we measure it is we do this using a benchmark way of measuring. We measure code quality and give it a score based on the benchmark. So we're not saying, here's a list of 1,000 violations that you need to fix, because AI engineers really don't like that, and for good reasons. We give them a goal that you need to reach this score, which means that some of the things that they're really fond of, and they're actually bad practices, but there's no good alternative in AI engineering and in data science. They can keep them, and then need to make up for that in other ways. And this fair measurement is really important, was what we learned with AI teams. They need it. And some AI teams are building quite short-lived stuff, experimental, and others are working more towards a system that will go into production. And what we believe in is setting the quality bar to the technology readiness level, is what we call it, of a system. So if it's just an experiment to find some pattern and then you throw it away, you can set the bar low. You need to have a bar, but it can be set low. And in Cigarette, you can also set the bar higher for projects that need to go into production. So depending on how experimental the AI is, you can get a fair judgment and fair, recommendations on how to improve this. So that's our platform. And apart from that, we do IT due diligence. So we look at a lot of AI systems. We take them apart. Our teams look at them under the hood, looking for issues to improve.
Maybe can you give one really concrete example?
One of my fondest projects was with a large company that we helped with engineering their AI systems. They had a big program to let AI do forecasts, but they had terrible problems with the code. And with the architecture being really hard to understand, hard to change, and therefore hard to transfer to other teams. And it even made their development come to a halt. And that's where we came in. We provided them with quality measurement, recommendations, and we had peer programming workshops where we taught the data scientists how to be good programmers. And you can see the light going on. You can see that, wait a minute, if I make an abstraction in the morning and create a function, then in the afternoon, I can actually myself benefit from it because if I make a test, I can read what I was doing. So they saw the light, and we were sort of filling in a blind spot that they have been lacking because the lack of feedback they have been getting and the way they have been incentivized. That took a while, but eventually the team saw the light, we made a big difference there.
I like how in the end it's software engineering, and the challenges are software engineering challenges.
Indeed.
We talked about GenAI. We talked about building AI yourself and the challenges that you see there. Let's step a bit back and talk about AI readiness. So as an organization, again, I think I opened with it where you think, okay, a lot is happening. Are we doing enough as an organization? And if we're not doing enough, I'm also a little bit scared of throwing us head first into the fray. So where am I? What do I need to have in place? How do you see companies preparing?
Well, they are preparing for sure, right? Boardrooms have not been living under a rock. So AI has become a boardroom priority. Everybody's working on it. There are some exceptions, but they are extreme exceptions. I think I saw McKinsey reporting that almost 80% of organizations already use AI in business functions, right, in production. However, with great opportunities come great challenges and uncertainties, and rightfully so. So it's good to be a little bit careful. AI readiness isn't just about technology, it's about organizational preparedness, governance, and a strategic approach to implementation. And many organizations are taking these steps, and it's wonderful to help them.
Okay, so what steps would you recommend? Not no specifics here. I guess it really depends on where an organization is or what domain is it in. But if you step back from that, what should organizations, specifically leaders in organizations, what can they do now?
Yeah, I have some pet topics there. Of course, there's 100 things that they need to do, or to be precise, no, there's 19 things. I wrote a little book called the SIG AI Readiness Guide. It describes 19 pragmatic steps, so not difficult, really handy steps for organizations to take. My big takeaway there is that it's important to wear two hats. It's essential to consider AI from both optimistic and cautious perspectives. One hat is the blue sky future hat. It sees AI as a powerful tool driving efficiency and innovation. And the other hat is the burning earth hat, which is about potential risks, privacy breaches, malicious use of AI technology. So you need to switch between optimistic and pessimistic in a sort of a believable way. And that requires personalities in the right place. If you put a completely compliance-oriented person who is used to looking at ideas and then saying yes or no in a place, that person would also need to have or develop a a mentality of enthusing, right? Showing what great things lie ahead and making sure that everybody tries things and is not scared, because you also have the other head sometimes on, and that's why you created the guardrails. And one other thing is that the blue sky hat needs to prevent getting mesmerized by all the promises. There's a lot of success stories and demos, but hallucinations are not going away. The fact that you need to apply meaningful review to the work of AI can turn a positive AI business case into a negative one. Just go out there, experiment, but keep, the business value in check, and just don't go ahead with the idea if it turns out to be negative.
I really like this burning earth as a counter. I'll remember that. But also to oscillate. I know people more on the burning earth that they don't take off that hat, and you have people who don't really not take off the blue sky hat. So I like that idea of balancing. So an important lesson, I think, in general is it's very hard to know what to do, but the best and that is for anything in life. But avoiding common mistakes is a good place to start. Right, so at least let's not do the most stupid things or the most common things that go wrong, and then we'll see from there. What do you see as the most common mistakes in AI readiness?
A couple of things. I've seen organizations create AI literacy training by sort of downloading some AI 101 training. That's not the goal of AI literacy training. AI literacy training needs to look at the organization. What specific uses of AI are there? What plans are there? What are the typical risks? And what do you want to set as a policy to control these risks? And how do you want to implement that policy? And all those things eventually lead to a couple of things that you want to teach the people developing and using AI, which is, by the way, in Europe, mandatory according to the AI Act. Using AI literacy training as a vehicle to build your AI program has, for us at SRG, been very, very helpful. So skipping that is not recommended. Also, treating AI in isolation, that's not a good idea. It's okay to have one AI committee and one AI program, but the trick is to make it work for the rest of the organization. You want to empower departments. AI innovation works best in the value streams. So if you create one team that needs to do all the AI innovation, that's typically a mistake, because then you create a bottleneck. And also when it comes to frameworks, no isolation. Don't try to set up an AI security framework, for example, but extend what you already have, because you have a lot of processes in place. You have your risk inventory, your assets inventory. Just extend it with the AI risks and with the AI assets. Don't make it more difficult than necessary, and it will be less overwhelming. Let's see what else. Compliance is important, is a driver, but some organizations base their entire AI policy on what regulation requires. And that's a big mistake, because the regulations focus mostly on the safety, health, and fundamental rights of the citizen. And we all care for it, but we also care for our business, right? So if you focus on just compliance alone, you will miss a lot of issues that can affect your business. If your business has downtime and you're losing customers, regulations really don't care much about that, unless you're running some electricity plant, and then you have an infrastructural feature that is tied to safety and health. But other than that, you're on your own, which means that you need to look with a broader view at your AI risks and not use compliance to create blind spot there, but use it as a driver for sure.
Nice. Yeah. So what I will really remember from your answer is the first part where you say, it's like an AI 101 is not AI literacy. And so I guess you're saying you could take a prompting course, but that's absolutely not the same. It's because that you see that happening a lot in organizations, especially not such technical savvy organizations, where hey, this is how you make smart prompts. But that is not at all what it is to be AI literate. That's very interesting. Maybe do you have concrete examples of where you or SIG broader contributed in this particular part of AI in the readiness?
Yeah, we extended our AI readiness guide with what we learned from our own AI literacy program. And if you look at the AI literacy training, it's just a workshop of typical cases that take place in our company, because those are the ones that resonate. And those are the ones that show the risks that we have to deal with. We're dealing with a lot of software source code from our clients, for example, which brings in special challenges. It's important that everybody understands those. Yeah. So actually, my first tip to people doing AI readiness is use that AI literacy program as a vehicle to go through all the steps that are necessary to know what you want to control and how you want to implement that in the organization.
And if we do that with a client, what is it that we do? What do we offer? How do we help with this?
We talk to the board. We do workshops with them. Typically, we assess the organization's readiness, provide them with a roadmap, and make it sure it fits their context and ambition. And we constantly keep building on that AI readiness guide. To plug it, just a few days ago, we updated the AI readiness guide, so listeners can find it in the show notes and download it for free.
What was the key new thing added?
Oh yeah, we sort of have the ambition of keeping our readers up to date with what goes on geopolitically. Famous last words. So we have to make quite some effort to stay up to date what happens around the EU AI Act, but also what happens in the US and in China. Yeah. But those are important background, information for our readers. So we extended on that, and we extended on the AI literacy learning, as I said. Yeah.
All the more relevant for it. Good to hear that it's being kept sharp. I can talk to you for a long time. I have many more questions actually, but I think we at least touched the three key topics that I promised we would talk about in the beginning of the conversation. Thanks. I always enjoy your sharpness and your insight. I hope we can do this again, because things move very quickly. So I can imagine new use cases or things really changing on some of the use cases we talked about.
Yeah, it's almost time already, indeed. Wow.
Yeah. So I hope we can do this again. Let's switch now, because so far we've had a conversation together where I could ask whatever I felt like, but we also have a mechanism in this webinar where attendees can actually ask questions, and I already see a bunch coming up. If you have questions and you're listening and you want me to ask of Rob, please share them using the Q&A function. Some of you already found that function. Don't hesitate. If we have too many questions, then we'll make sure that the questions are answered on our community. We have a community. We'll also share that information with you. We'll make sure that the questions that are overflow questions that don't fit anymore will be answered there. So feel free to add now. I'll open with the first question. You talked very cautiously in the beginning of the conversation when we talked about GenAI, Rob, about the role for certain solutions that will stay because the nature of LLMs. Yet, so many people talk about software development being something that is essentially going to be completely automated away in some near future. How do you look at this? Is this a matter of time, or is this overstated?
Yeah, so if we do this thought experiment, and if we think about the future, and there will be some moment where we have this new hybrid reasoning revolution in place, and AI can create perfect code.
Yeah.
Then you still have to tell this AI about the context of your situation. And maybe people think about, yeah, but we have this bridge club and we have members in how can that be difficult? Some things are simple, but
Yeah.
most organizations that we work with, very complex systems. And in order to specify what's going on in the real world, the many types of users, their roles, responsibilities, use cases, actions, all those complexities, you still need to specify in a way that is maintainable, is structured, it has reuse, it has encapsulation, which is essentially code.
Yeah.
So code won't go away until the moment that AI knows everything that we want and everything that we will ever need and create it for us. And that's why I have in mind this part of the movie Wall-E. I don't know if you can envision it, where people
more a burning earth head type of situation, right?
It depends how you look at it. I mean, if you like to lie on a floating bed all the time and watch cartoons, then that's the perfect future for you. But I think it's better to stay in control.
It's going to be fun for a little bit, but I think there it was indefinitely your faith, right?
Yeah, indeed.
I heard your second example, including involving Bridge. You gave one earlier. How's GenAI doing in Bridge? Is it something?
Oh, wow. Yeah.
I don't know. You might know. This is a long shot.
Yeah, I play Bridge. It's a very exciting question. Bridge is quite intuitive. I wouldn't say that a large language model or a transformer would be the perfect way to play Bridge. I mean, if you look at the technology in AlphaGo, I think that will be a way to do it. Yeah. When we're done, I'm gonna look this up. There's probably some great experiments there. Reinforcement learning is the way to do this.
Question here. So AI moves super fast. Is there anything you would have advised a year ago that you wouldn't advise now, or perhaps in a different way?
Yeah, there are plenty examples of this. An example that I often use is that back in the day, we were creating AI systems to do criminal profiling on an individual level. Everybody believed it was, for society, for everybody, the best thing to do. And later we concluded, whoops, there's too much systemic bias in police databases. So we're paying attention to the wrong groups. That's something that it's unethical. So we won't do it anymore. And now we're at a stage where just the AI Act is forbidding criminal profiling using machine learning on an individual level. So that's, I think, a good example of things that we can also expect to happen in the future, especially some of the ideas that people enthusiastically embrace now. And it's already happened. We saw organizations embracing vibe coding at a large scale and then firing development teams, and then a couple of months later deciding to hire them back again. As long as you don't go to a door through which you can't go back, then I guess that this is the perfect time to learn, and we'll learn a lot.
Yeah. And do you have any estimations if you look a year from now?
Right. Things that we get back to. One of the things, So one example is atrophy. It's a topic dear to my heart. If you let developers constantly depend on AI, you're ridding them of the ability to come up with a solution to a problem. And that solution or that process of coming up with a solution to solving the patience, the perseverance, but also the ability to write code, you're not practicing that as much as you were before. This will reduce the skill level of developers. And if we don't control this, I predict that the senior software engineers that we know right now are the last of their kind. So I predict that in a year from now, we have learned that we need to do something and they need to incentivize teams to actively engage developers in using their craft of software engineering and actually dumbing down the AI like we are dumbing down cars, because cars can do a lot more than they do now on the road. But it's not a good idea to make them almost perfect, because then you get accidents and people don't pay attention anymore. So I predict some learning moments in a year on that topic.
Isn't this problem exacerbated by the fact that when organizations do fire developers, and you read quite a lot about this, they will rarely fire the seniors because these are the people who can interact with an LLM to create better code, to actually have the skills to evaluate what an LLM is doing, and the juniors don't. So you have that even quicker puts a stress on your future senior population because you're not creating it.
To be honest, if you would ask me how this will evolve, it's hard to predict the whole team dynamics. What about the junior programmers? It's going to be an exciting time.
Yes, and a tragedy of the commons, right? So who then trains the developers? Nobody wants to pay for that, because if you have some seniors, you can just speed up with them. That's an interesting challenge. We talked about data scientists who are already. We already had this discussion before GenAI, where data scientists were writing big data systems, or systems that did stuff with a lot of data. This is in a way a variant of that, I would say. And I remember already then it was a problem because data scientists are not software engineers, and we just talked about the challenges that creates, and they're creating code as if they are software developers without any formal training. And you explained that but they need that, right? Because in the end they're building software systems, and it's problematic for organizations. But how do you convince them to do that? I remember software engineers complaining about data scientists. We're calling the business inhibition people. Shut up, we made something pretty, and now you're complaining that we need to rewrite it, and we're making money with it, right? So how do you convince data scientists that they're actually doing software engineering and that they should be a bit more diligent about that?
Yeah, we did that in these workshops where they really need some hand holding to really see for themselves what benefits it brings to themselves. What also incentivizes them is that if they are, for example, a startup, is to explain that, listen, guys, if you want to sort of make an exit and sell your system, if your new owner is going to look at how you've documented things and how you've tested things in your architecture, they're not going to buy you. In order to build something of value that will last, you need to do a better job. So that's an incentive for startups. And the other way to create an incentive is to simply set a bar on the quality of the software, which is notoriously hard for AI teams. The way we fixed it is to make it benchmark-based and flexible so that AI teams can decide for themselves on how they build in quality, and make that objective dependent on the technology readiness level. So by fair measurement and feedback, and providing them, with actionable recommendations, this problem can be solved.
Yeah, you already gave the example also earlier of if you figure out that it's really nice to have unit tests on your code, or that you use an abstraction, or the first time you need to use your own. I also did some data science in the past, and I vividly remembering looking at my own code and going, I have no idea what I'm doing here.
Same here.
Yeah, and then you spend most of your day rewriting that, where it's, you could have saved yourself so much time if you've done it. That's also, I think, the problem with software quality. Sounds so optional. Quality, sure, but we want to make money. Who cares about quality? Quality becomes a problem when it immediately benefits you, because you have to touch that code again, and other people also have to touch that code again, and nobody likes touching other code unless it's really, really good. Or really, really understandable. And it's so much easier to write that type of code than non-understandable code. It's just it's discipline. That's all it is.
Yes.
Interesting. Here, interesting question, because I remember reading something you shared a couple of days ago. Do you think AI-assisted coding is really making software engineers 10, 20, or even 30 times more productive? Or does the necessary checking lower that number? Sort of two questions.
I don't think so. I believe 30% is a more accurate. So that's 1.3, which is already gigantic.
Yes,
right. It's. I mean,
impressive. Yeah,
it's almost like free lunch. So that's great, and that's why we're embracing it carefully, hopefully. And the reason is that code generation is not the only thing that developers do. It's a lot about understanding the problem, working with others, specifying things, exchanging ideas, and writing the code itself is a small part relatively small part of the total work, which means that you can never make it 100 times as fast. Also, because you shouldn't measure just the speed of typing with the hand and letting the AI generate, because the AI generated code requires some scrutiny. It needs to be reviewed, it needs to be adapted, and it may have some issues that you will find out later as technical debt that then need to be fixed. So that additional reviewing and fixing, incorporating that is the only real fair way to measure the productivity increase.
Yeah, I also remember that maybe 10 years ago, maybe even 20 years ago, there were some measurements were taken of the amount of work, and you can measure that in function points or in churn on a code level. Certain developers could do versus other developers, and the spread has always been very wide. So you had these, and I think that old articles even mentioned 50 times. I think this is slightly exaggerated, but some people are just capable of writing so much more productive already. So it's really hard to see what the role of GenAI is in that, or how it can help those people to become even more effective. But we'll see way more research into that, I think.
One more thing to add to that, as you make me think of that, is that our research shows that 20% of the work is in generating the system, and 80% of the development work is in maintenance. And maintenance is changing code, and that's very different productivity-wise from give me a boilerplate of a front end with a login screen. Bam, there you have the code.
Sure.
But then you need to change things.
Yes.
And I think that also has a large effect on the productivity measure.
Yeah. So GenAI does great in greenfields. Indeed, the prompt you gave will yield impressive results. But here is my existing legacy system. Help me reduce the dependencies between back and front end, so I can replace the front end. That is not delivering anything interesting from any of the models right now, not even if you make it small. And talking about deterministic systems, if you could have a prompt that gave it an accurate architecture, that would make it far more powerful already. And LLMs will never be able to do that. And so you need these other tools to augment sort of if you look at this particular modernization scenario, you need other types of tools in that tool chain. You hinted earlier at startups and investment in AI. At SIG, I've also spent a lot of time in different IT due diligence projects where we look at what are you investing in, and does the technology that you buy or want to sell really support the investment case in terms of scaling. In your experience, what specifically changed in the past, say, year and a half when it comes to IT, AI as being part of this mix, in terms of the types of questions that are being asked, but also the types of findings that you then have?
It's quite hard for experts in IT due diligence to make sense of what an AI team has done.
Yeah.
Because you need to compare it to the state of the art, which is constantly evolving. So they have solved some very specific problem, and typically there's 5 papers on it, and there's an entire field perhaps working on this. And has this field perhaps already surpassed what the startup has built, or has the startup done something with an unfair advantage that is incapable for others to reproduce, which is the main questions in these, especially in mergers and acquisitions. And that's where you see where not per se the smartness of the idea is winning, but some other unfair advantage, like being connected to an early adapter that brings in a lot of domain knowledge, or having access to unique data where you have exclusive rights to. So it's really important to identify what sets this startup idea apart and how difficult it is to reproduce. And sometimes they have just been overtaken by events and actually became worthless. So the amount of AI expertise necessary to really make sense of whether it's AI gold or AI fake it's become really important.
Yeah, it's hard. ITDD is already in general, I think merger and acquisitions suffer a little bit from in-depth information about the technology involved, even though an increasing amount of deals are very software-centric, or at least software plays a very central part. But the view that teams often have on the software is limited. And I think that problem only got much, much bigger. And I think your examples are very apt there. There's also no simple solution for it. You really need to try to figure out these things and take the time to make sure that you're not investing in something that is already, as you call it, AI fake or yesterday's news.
The nice thing about these projects is that these data scientists love to talk about their pet project, and it's just a lot of fun. And sometimes it's really amazing to see what
boring. No, no, yeah. Okay, one more maybe. So this one is what you often see is organizations reporting at some outlet, sometimes LinkedIn, that so many developers have been fired. And you gave the example of teams being rehired, but I think you read more about firing than rehiring. That doesn't mean it happens more often, but at least that's how it's being advertised. Do you, with what you know, what sort of your instinct there, is that really about GenAI, or is that also a very nice mechanism to change things in the organization?
So here's where I want to set an example, and and this is also a bit of a pet topic of mine, which is expertise about AI is in high demand.
Yes.
And it's always hard for an expert to say, I don't know. And the primary thing I would like to recommend anybody that's doing things with AI is create an atmosphere where AI experts or supposed AI experts are allowed to say, I don't know, so that you can sort of conclude that you don't know and that you have to find out. Because the biggest risk is AI experts saying, well, I think it's blah, blah, blah. It looks good on webinars. It sounds really, thought leaderish, and this person knows everything. I'm going to set the example of saying, Werner, I just don't know.
Nice. We'll look it up. And also the bridge question, right? You also don't know. So you did it earlier, true to your own advice. Well, I'm curious. We'll talk about it later. I've actually more questions here, but I'm going to close up the session in a little bit. You can go to the community. We have a community. We'll share that information with you to ask your questions. If you have other questions that you really want answered, you can also find Rob there. I'm there too, if you're interested in technical debt. But I think when you have AI specific questions, definitely ask Rob, because if you ask me, I'll ask Rob. Thanks a lot, Rob. I really like talking to you. And again, I hope we can do this in a year when the world will look very differently. I want to hear from you where we are then on all these topics we talked about. Thanks a lot. And I wish you a nice rest of the day.
Thanks, Werner. It was fun.
Bye.